Hello everyone, let's get back to another video for lecture 2, and this lecture we will mainly focus on the lines, circles and the parabolas. In the previous sections we identify the points on the line with the real number by assigning them the coordinates, and these sections we will provide you the review of the coordinates, the line, the distance, the circles, and also the parabolas in the planes. Okay, the Cartesian coordinates in the planes. So if you have remembered from your high school mathematics that we also have the Cartesian coordinates, which has two main axes, which is the x and the y's. The point in the planes can be identified with the other pair of the real number, so which means that the point in the planes need to lie on the x and the y. And don't be confused these notations with the notations of the point, right? So if you could remember from the last video, we talked about the real lines, and this is the example of the real line. For example, you have the point x and the okay, let me go back to that, the point x and the point y. And if you see that this is the circle parenthesis here, which means that we do not want to include the point x and we do not want to include the point y. All right, so the point that we are looking for is right between that two number, the x and the y. But in this case, the Cartesian coordinate here, which means that you need to have 2 points, that is the point x and the point y, so that you can be able to point out or plot out the positions of that point with lines in the planes. And to begin with, we draw 2 perpendicular coordinate lines that intersect at the points of 0. So let's say this one is the y-axis and this is the x-axis. So now we have 2 perpendicular coordinate lines, and here at the intersections, let's say that this is the coordinates or 0 of the origins. On the horizontal x-axis, we can denote that by the x, okay, x-axis, and increasing to the right hand side of your hands, and along the vertical axis we call that as the y-axis, and increase or going toward the positive y. And we also have the downward for the y, which is called the negative y, and also toward the left along the x-axis, okay, which is the negative along the x-axis. Right, so here is the coordinate in the planes that we talk about. So normally we can divide that coordinate of the planes in 4 sections or in 4 regions. So the first region here is located along the positive x and the positive y's, whereas the second region here lie in the left hand side of the x-axis, which is the negative, and along the positive y, okay, negative x and positive y's. And the third region is lies in the x and negative x and the negative y axis, meaning you go to the left side of the x and going downwards of the y along the vertical axis. And the fourth sections of the fourth regions here, when you have the point that lies in the positive of the x-axis and negative of the y, meaning downwards along the y directions. And again, here I point out to you that we have the origins of the planes located at the x equivalent to 0 and the y is also equivalent to 0. We call that point or that positions at the origins of the graph or the origins of the plane. Right. when you move from the first quadrant to the second, to the third, and to the fourth, like you can see from this figure, you can see that we move the directions of the quadrants in the directions of anti-clockwise. Okay, as you can see from that figure. And just emphasize you again here, the first quadrant is located along the positive x, positive y. The second quadrant is located along the negative x, positive y, whereas the third quadrant is located along the negative x and negative y. And the last one is at the fourth quadrant or the fourth regions, when you have the point x in the y directions toward the positive x and the y is going downward. Okay, so next example 7, describe and sketch the regions given by the following sets. So here in part A, I give you the x and y, and then I give the definitions for the x when the x is greater than or equivalent to 0. So in this case, we know that the point whose the x coordinates are 0 or the positive is lies on the y or to the lines of the x-axis. Alright, therefore the shaded regions in part A should be given in this format. Like as you can see, if we want the x that is greater than or equivalent to 0, you should first draw the straight line where the y is exactly equivalent to 0 and the x is also equivalent to 0, but you need to give the shaded region for the positive of the x because it's going toward the positive infinity. That is for the part A. And how about the part B? So in the part B here, we have the point x and the point y. So it means that you need to have two coordinate systems and the value of the y is exactly at the value of 1. So at exactly the value of 1 means that you need to have the horizontal lines above 1 unit. Okay, 1 unit above the x-axis. And here is the sketch of the regions that we want the graph when the y is exactly equivalent to 1. So you can just plot the horizontal straight lines 1 unit above the x-axis, just like that. And the last one, how about if you want to plot the value of the y, but this time it's not just the normal y, but it is the absolute y. So remember the absolute y here in the rule of the absolute value, absolute y less than 1, which means that you need to have two value or you need to put the interval for the absolute of the y, meaning that we need y which is less than 1 and y which is greater than -1. Okay, so you need that. And then we can plot out the regions that we are looking for. Therefore, in this case, we want the regions of y to be less than 1, which means that we start with the horizontal line at exactly y equivalent to 1. But you can see and notice that in this case, we do not write the straight line. Okay, the solid straight line. But in this case here, we write it in the dot line. Okay, we write it at the dot line, which means that we need to include the value of y which is less than 1. Okay, but not exactly equivalent to 1. And also, sorry about that. And also, the next one is the value of y is greater than -1. Greater than -1, which means that you go up to the x-axis. Okay, from y equivalent to -1 here, and the value of y equivalent to -1 will not be included in that shaded regions. Okay, and here is the sketch of the regions that we are looking for. Alright, Next one. In the example X, in going from the point A, where the point A is located at the position X equivalent to 4 and then Y equivalent to -3, which is at these positions, to the point B, where the point B is located at the X equivalent to 2 and Y equivalent to 2. This one here. So in this case, we're going from A toward the B. So going from one position to the next final positions, we call that as the increments. So in this case, we have 2 points, which is the X and also the Y. Therefore, we need to have 2 increments in both the X coordinates and the Y coordinates. Let's say for the X coordinates here, we go from 4 to 2. Therefore, you need to start with the final point at B, and the value is equivalent to 4, and then minus with the initial point at the value of A, which is equivalent to 4. Therefore, the increments of X in this case is about -2. And how about the Y? So we're going from, remember, we're going from A to B. Therefore, we have to start with the final point. Okay, we have to start with the final point Y of the B first, because this is the final point, and subtract with the Y point in the A, where the final point on the B is equivalent to 5, and then the initial point on the A point is about -3. Therefore, 5 minus -3 is becomes 8 in this case. So this is the increments between the 2 points, and then you will have the increments along the 2 coordinates axis, which is the X and which is the Y. Another example here, if you want to go from point C here down toward the point D. So again, you will have the increments along the X and increments along the Y as well. So along the X here, we have to start with the X final, which is 5 minus with the X initial at C, which is 5. Again, it becomes 0, means that along the X-axis, there is no change at that point or at that axis. And how about the Y? So the Y in this case, remember that we're going from C to D. Therefore, in this case, to find the increments in Y, we have to start with the point Y at the point D, and then subtract with the points Y at the point C, which is 6. Therefore, the increments in Y would be equivalent to -5. Okay, so that is how we can find the increments along the X and along the Y coordinates from the given 2 points. Right, and based on the increments, we can make use of that increments to find the slope of some planes or the slope of the lines, which we call it as the lines and the lines. So the lines here, which means that you have the increments along the Y-axis, whereas the lines meaning you going along the ground at the ground planes, which is the X-axis, right? Therefore, the slope here can be estimated from lines divided by the lines. In other words, is it the increments in Y divided by the increments in the X, or y2 minus y1 divided by x2 minus x1. So in this case, if you have y2, y1, x2, x1, such things that you already have 2 points. One would be the final point and another one would be the initial point. So that is the definitions of the slope, the lines in the y coordinate, divided by the lines along the x coordinates, and then you can find the slope of the given point, given 2 points, right? And next, the slope here. After we find out the slope, the value of the slope will tell us 2 things. The first one is the direction, whether it's go uphill or it's go downhill. And the second thing is about the stiffness of the line. A line with positive slope lies uphill to the right, and another line with the negative slope falls downhill to the right. Okay, so that is the difference between the directions which tell you up or down, and then the stiffness, that means in the quantity number. The greater the absolute value of the slope, the more rapid lines of fall. The slope of the vertical lines is undefined. Why is that? Because there will be no ending point, or there will be no intersection point, so you cannot be able to identify the slope of the vertical line. Since the length delta x is 0, okay, remember that if the delta x, suppose you want to find the slope m, another way is that you have delta y divided by delta x. So along the vertical axis here, you have 0 in the delta x, but you have some value for the delta y. Therefore, any value divided by 0 would be undefined. That is why the vertical line has no slope. Right. Let's look at this figure. You have two lines. The blue one is for the L1 and the yellow one is for the L2. So you can be able to find out the slope for the L1 and also the L2 by using the definitions of the slope. The lines divided by the length, where the line is represented for the increments along the y coordinates, and the length is for the increments along the x coordinates. So for the L1 here, as you can see, we go from the point P3 and then up to the point P4. Therefore, when you have to find out for the increments in the y, you have to use the final point, okay, at the point P4, and which is 6 for the y coordinate, and the point P3 which is -2 along the y coordinate. So 6 minus -2 is become 8 divided by the length along the x coordinate. So along the x coordinate, you have to start with the x final, which is 3 subtract by 0, which is the x initial. So in this case, the slope for the L1 here would be about 8 by 3. So 8 by 3, this number here, or this slope, it indicates that the y increased 8 units. Every time the x increased 3 units. Okay? And next example, if you have the L2 here, and then in this case, you want to go from P1 down to P2. Therefore, for the delta y, or the increment in the y, you have to start with the y final, which is 2, minus the y initial, which is 5, and then you divide that by 4, which is the x final, and then subtract with the 0, which is the x initial, and then you will have -3 by 4. So this value, m equivalent to -3, can tell you that the y decrease every 3 units. Okay, y decrease 3 units every time that the x increased by 4 or increase 4 units. Okay, so this is the definitions of the slope. After you find out the number for the slope, then you have to be able to interpret the meaning of the value. And next is the point slope equations. So in the previous slide, we have be able to show the value of the slope, or the m, the lines divided by the length. In other words, it is the increments along the y divided by the increments along the x coordinate systems. So if you want to find the point slope equations, remember we have to focus on we have to first find out the value of the slope first, and then we plug in that value of the slope. So this is the exact point slope equations that you need to stick with. So you have y minus y1 equivalent to m, and then multiply with x minus x1. So these y1 and this x1 tell you the final points of the x and final points of the y. Therefore, this is the point slope equations. Or if you prefer to move the y1 to the right hand side of your equations, you can also do that as well. Therefore, the point slope equations would be equivalent to y and then equivalent to the term here. Okay, so that is the explanations for the point slope equation. So let's take a look in this example together. In this example, I argue two lines and equations for the line to the point 2 and 3. So in this case, we know that x equivalent to 2 and y equivalent to 3 with the slope minus 3 by 2, slope minus 3 by 2, which means that the value of the m's is equivalent to minus 3 by 2 here. So remember from the previous equation for the point slope formula, you have y minus y1 equivalent to the value of the slope multiplied with x minus the x1. So in this case, let's focus that the 2 and the point 3 is the final point, or is the point where the line is passing through. Okay, so you have y that is equivalent to 3, and you have the value of the m's or the slope, which is minus 3 by 2, and then multiply with the x. This x here is constant variable, and then x1 here would be equivalent to 2. It's already given to you from the equations. Therefore, this is the equations for the line passing to that point and the slope about minus 3 by 2. Or you can just move minus 3 to that side, and then therefore your value of y would be minus 3 by 2 multiplied with x minus 2, and then adding up with 3. Right, so when x, let's try this one. Suppose I plug in x equivalent to 0 in this case, then I will know the line intersects with the y-axis at the y equivalent to 6, or you can just try to plug in any value of x and then you get the value of y, and that value of y will tell you the line intersects y, the line that intersect with the y's coordinates at some positions of the y. All right. Next example, if you have a line through that's passing through point, so line equations for the line through minus 2, minus 1, and the second point is 3 and 4. So in this case, let's focus on the figure first. So you have the point. The first point is minus 2 and minus 1, and the second point is 3 and 4. Then you are asked to find out for the equations of the line that's passing to these 2 points. So you have to find the slope first, right? So you have to find the slope first here, and then after you finding out the slope, you can just plug in the slope back to the point slope formula. Remember the point slope formula, you have y minus y1 equivalent to the m's multiplied with x minus the x1 here. And the value of the m basically is either lines divided by the length or the delta y divided by the delta x. So in this case, if we take a look here, we have the value of the y that is the minus 1 and 4. So in this case, if we take a look in this slope, it seems like you are going from 3 and 4, the point 3, 4, down to the points minus 2 and then minus 1. Why is that? It's because you're starting with the minus 1 first at the final point, and then deduct by the initial point, that is the 4. Okay, and then you get the value of 1. And after that, you can try either point. You can plug in y1 and x1 as the minus 1 here for the y and minus 2 for the x, or you can just try 4 here for the y and 3 for the x, and then you would get the same equations for the point slope formula here, which is y equivalent to x plus 1 and y equivalent to x plus 1, the same, right? Therefore, either way, if you use minus 2 and 1, or if you use 0.3 and 4, the equations of the line would turn to be the same. Okay, so that is the concept of using the slope to find the point slope formula. Right, and next, after you find the slope, you should be able to know the intercept. What is the intersections means? The intersections means, for example, here in this figure, you have the point A, you have the point B. So x-intercepts or the non-horizontal line is the x-coordinates of the points where it cross the x-axis. Intercept basically is mean the point where the line is passing to or where the line is crossed at that axis. For example, for this case, it's the A, and along the y is B. So you have both x-intercept A and y-intercept B. Therefore, the equations y equivalent to mx plus b is called as the slope-intercept equations. Okay, don't be confused with the previous point slope equations that we have talked about. This one is the slope-intercept equations. We have to find the slope first, the same as the point slope equations. But in this case, after you find the slope, you have to find the intercept, the point where the line is crossed to the y-axis or the x-axis. Okay. Right, let's look at the example here. In this example, you are to find the slope and the y-intercept of the lines x plus 5y is equivalent to 20. So before that, you need to find or you need to rearrange the given expression first. You need to rearrange the given expression to be in terms of y is equivalent to mx plus b. You have to rearrange first, and then you can point out what is the value for the m's, what is the value for the b. So in this case, if you can see, we take the plus xx to the right hand side of the equations. Therefore, we have left with 5y is equivalent to minus xx plus 20, and then we move 5 to be divided on the on the right hand side of the equations. Therefore, we end up with these equations, the point slope equation here. We have y equal not point slope equation, the slope intercept equations. We have y equivalent to minus x by 5x plus 4. So if you compare that expressions with the slope intercept equations, you can map between the value of m and the value of b. So in this case, minus x divided by 5 is the value of m, or which is the slope, and then the plus 4 here, or the 4, is the value of the y-intercept. Okay, is the y-intercept or the b, right, which is equivalent to 4. Right. I think I will continue these parallels and perpendicular lines in the next video, and that will be the last video for the lecture number 2 about the preliminary. Thank you for watching, and stay tuned for the last video of this lecture 2. Bye bye.